So Aisha, I'll just ask you to share your screen so we can see the questions that your teacher assigned. Okay, so get ready for grade 10 chemistry, a review of grade 9 chemistry. So grade 9 chemistry usually is very basic. We go over definitions and just a basic like framework to actually dive into the world of chemistry. So let's start by matter review. Use the terms given below to complete the following matter concept map. Each term is used only once. Okay, so what is anything that has mass and takes up space? Okay, so what is like the most general word to describe I don't want to say the answer, but to describe anything that has mass and takes up space. Aisha, if you know the answer, can you please unmute?
Oh, so it's a term? It's like a term name?
Matches the first description.
Use a term to complete the following matter concept. Anything that has mass and takes up space is matter.
Yes, matter, okay? So matter is a very general term and it refers to anything that has mass and takes up space. You can think of like any food, any item, anything really can be considered matter. Okay, now matter is divided into two categories. We have particles that are all the same, so only one visible part or phase, and then another category is two or more pure substances, so one or more visible parts or phases. So this is where you have to choose between homogeneous and heterogeneous. So Aisha, which one do you think it is?
So
Also, your volume's very low. Do you think you can fix that?
how about now?
It's still pretty low.
How about now?
Oh, 1 second. Yeah, I think it's better. Okay, thank you.
Okay. I don't know. I think.
Okay, so let me tell you for now. So homogeneous is when particles are all the same and there's only one visible part or phase. So you can think of like apple juice, right? In apple juice, you just see like one consistent kind of like thing versus like a fruit salad or like a chocolate chip cookie, for example. You can really distinguish like the different parts. So when one or more visible parts or phases are visible, then that's heterogeneous. And if it's just one visible phase or part, it's homogeneous. Okay, so now we have to break each of those categories into two different examples, I think. Okay, so let's say homogeneous. Let's start on the left. Okay. So homogeneous, something made of blank. Okay. So you can so there's two categories of homogeneous things. We have
Does that have to do with a mixture and pure substance? These words or neither?
okay, so let me tell you okay, let's first put some words that we think make sense and then we can always like move them around, right? So for homogeneous, we would have
Look.
okay. Okay, how about we do the second row first? Okay, so Na is actually sodium, and that is a single element. So you would write element there.
Oh.
Okay, and then NaCl, that's sodium chloride, and that is considered a compound.
Sodium.
Oh wait, you can actually write sodium and sodium chloride.
Yeah.
Okay, yeah, write the actual names, sodium and sodium chloride, and then above, put element there.
Sodium.
Na is sodium, yeah. And then that is sodium chloride. Awesome.
Yeah.
Okay, awesome. And then above sodium, so in that box above sodium, you're gonna write elements because sodium is an element found on the periodic table of elements.
So on the bottom line.
I think you should put on the top line for now. So write element and yes.
Okay. Element.
Okay. And then on the other side you would write compound, I think. Right, because you can have a compound, but it can still visibly look like one phase. So yeah, okay. Now let's see. So we have what other options we have? We have um two or more atoms. We have
Mixture.
solution. Yeah, mixture and solution. Pure substance. I kind of like that. I kind of want to put pure substance made of elements. Actually, okay, wait, let's first do the other side and then we can see which words fit better, okay? So in the such as, let's first do such as a. Okay, we would put pizza there. And then on the other side, you would write I have to see the options again, sorry. Pizza and
Pop.
pop. The thing with pop is that pop is just one kind of, it's a homogeneous solution. Yeah, pop is homogeneous. I'm looking. Okay, how about you go down for a bit? Okay, more down. Okay, so something can be broken down into atoms. Blank can be broken down into atoms. Compounds can be broken down into elements using chemical processes. Okay, so I'm just thinking. Where will the can and cannot be? Oh, I know. Okay, so you know where it says be broken down into atoms? You would put cannot, right? Because a single atom of an element cannot be broken down to atoms, and then sodium chloride can be broken down into atoms.
Okay. So what I can do is.
Yeah, it will help if you cross them out. Just, yes, awesome.
Did we do mixture?
I don't think so.
Nope.
I want to double check that. Okay.
Okay, yeah, that's all. Oh.
Okay, yeah. So now, okay, so now let's go down.
Is that? Does it? Okay, never mind.
Okay, now also called
Also called
Okay, so where it says also called I think you would put mixture. Because yeah, I don't really know if it goes anywhere else. So yeah, right, mixture there. Okay, and then we didn't use pure substance yet. Are you sure?
Or maybe element made of pure substance? Or compound
No,
made?
right? Pure substance made of element. Okay, and then on the other side,
Hmm?
so where it says wait, what other option is there? Like kind of opposite,
Can you
not
see?
opposite to pure substance, but
Can you see like this? Because it makes.
hmm. Oh wait, how about you write mixture made up of two or more atoms? So where instead of compound, get rid of that. Okay, write mixture there, and then write two or more atoms, because you can have a homogeneous mixture, which is actually like two or more atoms. Okay, awesome. And then okay, so you wanna cross those out.
So mixture, and we don't have compound anymore. So get rid of that somehow. Com. Okay, that's
Uh-oh.
okay. I don't think I can erase it, but it's still there.
Can you just like put a dot beside it so we know we still have it? Yeah, awesome. Okay. Okay, so heterogeneous. Oh, we finished. We you have to cross out pure substance because we used that, and two or more atoms.
We have
Okay,
pop.
so we only have compound and solution left. So I guess that's what we're putting.
We still have in our box.
Okay, so you're gonna have to move pizza to the other side first of all because it says two or more phases. Yeah, and then you put compound on the other side. Replace it with solution.
What? Oh, like this? Switch?
Yeah, yeah. Okay, solution mixture is only one phase. Okay. So okay, now you have to tell wait, you have to get rid of mixture there
Where?
below no, not there. The other no, yeah, that mixture. Okay, and figure out which word we didn't use.
So compound, pop, and that's it. And solution. Compound, pop, and solution.
Okay, so pop is not we use pop.
Oh, we didn't.
Cross out pop.
No, we didn't put pop yet.
Oh, we didn't? Okay, that's a homogeneous mixture. So I wonder why we didn't. Go down. There should be space for pop in homogeneous.
Nope.
There isn't?
Nope. It's a solution, so I'm pretty sure it goes here.
Okay.
Okay, also called A. So we only have. Yeah, no, we did compound as well. Compound is gone. Right? So all we have left is solution. No, we did solution. We done all of them.
It says each term is only used once.
Yeah. So wait, 1 second. ABC 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14. What? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, there are 16. So we didn't do one of them, and I don't know which one that is. Oh, you know which one we didn't do?
Which one?
We didn't do atoms. Look, it's nowhere.
Okay, atoms. Okay. So that would go. Instead of element, write atoms. Can I have element? Where should we put element? Let me think. Instead of pure substance, I want to say you put element.
Here?
No, where it says pure substance.
Pure substance. Oh.
Yeah, okay, write element there. And then on Google search pure substance. I think I might have mixed up the definition for that.
What do I search?
So just on Google search pure substance definition. Okay, so pure substance does not have to be a single element or compound. It is called pure substance such as water, air. Okay, what does it say on the right where it says about? Okay, right? Is pure substance heterogeneous? I'm pretty sure it's homogeneous, which is why I'm confused. Okay, it's a homogeneous mixture, right? Okay, so go back to your work. The thing is that we need to put pure substance as a homogeneous mixture. Like, do you see the problem here? Okay, where it says mixture, get rid of that.
You know, I think there's the answers as well. She also provided them for when you're done.
Okay, yeah. So let's just do whatever we think, and then we can double check it. Okay, then what was there? Mixture. Put mixture. Where the last place that there's space. Okay, awesome. So let's go to the next page now. Or do you want to check the answer first?
Yeah, we can check the answers. Let's get to the work.
Okay, yeah. Let's check the answers.
Oh, it's not. That page isn't there. Oh, it is here. Okay. So we
Okay, so matter is pure substance and mixture. Let's see what we did. Matter is.
Oh, what? Look, there it is. Homogeneous and heterogeneous.
Oh, that's how they divide it. Okay. No wonder I was so confused. Elements and compounds go on the other side. Okay, you might have to move stuff around a bit, but it's fine.
Let me just do that quickly. So homogeneous. No. Homogeneous and heterogeneous. Okay. Then here's elements made of compounds. I think we got that right. Yeah. No.
Yeah. Elements may have atoms.
No. Does that say?
Wait, it's right. It's right, bro.
Yeah. Yeah. And compounds made of two.
Compounds are made of two or more atoms. I feel like that's what we had before, but then we changed it because we didn't know what else to put.
Such as sodium. We got those right. I know. Cannot and can. Let's see. Cannot and can. Right. And solution. We have mixture here.
Okay, like I knew that was wrong, but like I didn't know what else to put because we messed up the homo and heterogeneous. I put it like one thing ahead, and that's how I was confused.
Okay.
Anyways, but we got that going.
Pop, right? I moved it, but it was right. Pop. And beside it should be pizza. Yep. Pizza. And the word pure substance go? Pure substance goes here, up there. Okay. Pure substance goes here. Yep, that's it.
Okay, so the first classification is pure substance and mixture. So we have pure substances and we have mixtures. Pure substances and mixtures. And then we go on to saying a pure substance consists of elements and compounds, and a mixture consists of homogeneous or heterogeneous. Those are two categories, and then elements like sodium, sorry, and then we have compounds like sodium chloride. Okay. Awesome, awesome, awesome. Great job.
Okay,
Okay,
let's
let's
do
move on to the next page. I want to get through this real quick.
it. Okay.
Right, and then you can always come back and check these definitions because these are obviously very fundamental, very important. Okay, so physical and chemical properties review. So use the following key terms to fill in the blanks provided. So we have chemical properties, physical. Are you saying something?
Can I read? Can I read?
Fine, yeah.
Use the following keywords to fill in the blanks provided. Chemical property, physical change, quantitative physical property, chemical change, physical property, qualitative physical property.
Okay, so are you familiar with these words?
I think I heard of them, but I don't remember anymore.
Okay, so the first description, do you want to read it?
Any property that can be observed or measured without forming any substance, for example, color, mass, height, and odor.
Okay. So okay, so that has to do, so now we're not forming a new substance, okay? So when we're not forming a new substance, that means there's no chemical like changes happening. So that's definitely non-answer. Okay? Physical change, um physical change is not a property per se. Like if you kind of like understand that, right? It's not a change, it's a property, okay? So anyways, a physical property is something you can observe, like color, mass, height. These are all physical properties. So if you can write physical property, physical property, physical. Awesome. And then another answer that really like stuck out to me right now is a characteristic of a substance that can be measured numerically. Another word for numeric kind of data is quantitative, right? The quantity has to do with the numeric numbers. So put quantitative physical property, right? Mass and height are physical properties, but they're also quantitative because you can put a number like 10 kg to mass or like 6 feet to height. Okay, now a characteristic that cannot be measured, but we tend to describe it, for example, colors, is qualitative. Okay, because we kind of express the quality of the substance, like what's the color. Um, I want to say another example, but it's not coming to my mind. So the one above it is qualitative physical property.
Oh,
Qualitative.
qualitative physical property.
Okay, now the next three should be simple now that you kind of understand the difference between qualitative and quantitative. So I want you to just fill out the rest of these. Okay, I'll give you a minute and then I'll explain why you're right or wrong. Yeah. Because in order to create a new substance, you have to chemically change the like you have to chemically alter something.
What are you saying?
Okay, so basically I'm trying to hint that this is a physical change. Right? No new substance is formed, but we have a change of state, or we have a change in appearance.
Yeah, that's what I meant to write.
Okay, so I don't know if you want to switch them.
You want me to switch them? Hello, you want me to switch them? Hello? Do you want me to switch them or what? Hello?
Hello.
Hello? Hello?
Yeah, I can hear you now. Okay, yeah. So I was saying you have to switch chemical and physical, the last bottom two.
Which one should I switch it with?
With the one underneath.
No, chemical property or chemical change?
That one is this one's okay, wait 1 second. What did you do? Okay, look in the definition. If it says any property, like
Yeah.
let's say, yeah, that one where you wrote chemical change, it's a
Yeah.
property. They told you it's a property.
Yeah. So
So what are you gonna write there?
change.
Okay, and then when it says change in appearance and composition, formation of new materials and molecules, that's a chemical change. Okay, awesome.
No.
Where is it going?
Ah,
Excuse me, where is it going?
no, you're ruining it.
No, you were right. Why'd you move chemical change?
You were wrong.
Okay, let me explain all these terms because you seem a little confused. Do you want me to explain?
Yes.
Okay, first double check the answers. But I'm like 100% sure it's right, but
Okay.
still just for your own satisfaction. You're in the wrong. Yeah. Okay, so we have physical property, qualitative, quantitative,
Qualitative
chemical, physical, chemical.
property,
Okay.
change, and change.
Okay, now let me explain to you. Okay, so physical property is any property that can be observed or measured without forming a new substance. So the key phrase here is without forming a new substance, because we are not altering the chemical like composition in any way when we are observing the color, the mass, the height, the odor. These are all physical things that we can observe, right? And it's not affecting the chemical composition at all, right?
Mm-hmm.
You just take a ruler, or you just look at a color and you observe it, right? Okay, now qualitative, do you get that?
Yes.
Okay, awesome. So qualitative, you think of quality. Okay, so quality is something that you can describe but not measure it. Okay, so the quality would be like, what is the color, or I don't really have any other examples, but you get the point, right?
Yep.
Okay. I guess odor would also be a qualitative physical property, because there's not like like any kind of ruler or any like number you can really put to it, right? So that's also quality. Would be like it smells bad or it smells um you kind of like you just kind of describe orders. Okay, now quantitative. Okay, quantity number. So that's how you remember that one. Okay, mass, height, anything you can measure is quantitative. Okay, now chemical property is where when it says when forming a new substance. When you hear it's forming a new substance, it's how a substance reacts with another substance. Okay, even in the description, they said the behavior of a substance during a chemical reaction. Okay, so that is a chemical property. We're altering the atoms and the actual like composition of it, so it's chemical. Okay, now physical change is when there's no new substances formed, change of state, change in appearance. What did I say about physical change when you wrote that? I said something about like ice. Do you wanna tell me?
Yeah, ice is a physical change.
Water to ice, right?
Water to ice is a physical change when it
Yeah,
freezes.
so those changes in state, you still have the two hydrogen atoms and one oxygen atom. It's the same like chemical composition, but it's just different like not different arrangements. I want to say different arrangements, but that might confuse you. But just know that it's a change of state. Okay, now chemical change, last one, is at least one substance with new properties is formed, change in appearance and composition, formation of new materials and molecules. Okay, so that's pretty self-explanatory. We are definitely adding more atoms or changing the whole like fundamental buildup of that substance.
Okay, next.
You good with that?
Yes, ma'am.
Okay, so start reading number 2.
Okay. Okay. One of the main ideas of science is that matter cannot be created or destroyed, but matter can change. When a chemical change occurs, there's usually some evidence or indicator.
Okay, so they didn't give us any words here, but I'll just tell you what I know and then we can double check. Also, the textbook would have had all the answers to be honest, but we're still gonna do this. So the indicators of a chemical change are a new color appears. So write color. Okay. Blank is produced or absorbed. I am thinking indicator of a chemical change.
How about bubbles?
Okay, skip this one for now. Right in number 3, a gas is produced. Gas, yeah. The next one is a precipitate forms in a liquid.
How do you know this?
We learned it. Okay, and a reaction is hard to reverse. This is very simple stuff. Like you have to know it. Anyways, blank is produced or absorbed. Let me think about this one. So if you have a chemical change, you would have either a new coloring appearing, a gas is produced, precipitate, reaction is hard to reverse, something is produced.
What about
What?
bubbles? What about bubbles?
Bubbles is like that's like an indication that a gas is produced. You know, like when gas is produced, you would see those bubbles.
Yeah.
I would say search this on Google, the indicators of chemical change. Okay, because the last one, I'm not exactly sure what it would be.
What's wrong? Oh, 1 second.
N- n-
Indicators of chemical change.
A chemical change. Okay, so let's see. A change in temperature. Yes. Okay. Oh, production of an odor. Okay, an odor can also be the one. Change in temperature, odor. Okay, let's see which one fits. An odor is produced. Actually, I don't think an odor is absorbed. I think you would, yeah, I think you would put gas on top and an odor at the bottom.
How could a gas be absorbed?
I think you can absorb a gas. Okay, let's check it with the answers now.
Okay. Heat is produced or absorbed.
Oh, yeah, it had to do with temperature. Okay, yeah. So that's heat. And I
Okay.
think it said a gas is produced. Yeah. Okay, gas was right there. So change it back to gas. Or you wrote odor.
Oh,
Yeah. Okay, it was gas. And then the other two are,
if
just double check with the answers.
or solid.
Precipitate and reverse. Okay.
I'll just write or solid.
So slash solid, yeah. Slash solid is good.
Okay.
Okay, and then a reaction is hard to reverse. Awesome. Okay, now chemical gas tests are useful to help identify unknown gases that are given off. Okay, so there's three main like chemical gas tests that you would do if you have like an unknown gas. How would you test to know which one it is? Okay, so oxygen gas. So oxygen gas is indicated if blank when placed in a gas when blank. So this is a burning spindle, I think. A burning sprint. A burning sprint, right? A burning sprint.
What's a burning sprint?
Actually no. Wait 1 second. It's not a burning sprint. It's I don't know if it's called a flaming sprint. Wait, let me think. Let me think. So oxygen gas is indicated when you have, like when you have a piece of wood and it's like burning, but it's not actually like a fire.
Yeah.
There's a word for it. Okay, it's like when it's not burning, but then when you put an oxygen gas, it will start to like actually like combust. Right? It says it burns more when oxygen is present and more concentrated. So the word for it, I don't remember, but it's okay. Let's move on to carbon dioxide gas. Carbon dioxide gas is indicated when, right? A burning splint here. A burning splint is extinguished. Extinguished. Not oh yeah, extinguished, I think. Okay. Or when some blank. Okay, and a water vapor, let me see what water vapor. Goes on 1 second.
Oh.
Is indicated if the um honestly I think it's I think if there's like condensation on the glass, right? Condensation in the container. Okay, we're gonna check the answers for this one because I know the wording will be very exact. Burning, okay, for oxygen gas, get rid of burning sprint because it's called like a flaming sprint. It's called something else. So just get rid of the word burning. Okay, now check your answers for this one. Oh yeah, hydrogen gas is indicated by a hydrogen pop test.
Oh, I remember those.
Oh, you remember that? Yeah, it's really nice. It makes a really like pop noise. Okay, now check the answers for this one.
Glowing splint. You're so close.
Glowing! Yeah. I was like, there's a word for it.
Splint. Okay.
It's reignited.
Yep.
Or
Wait.
burst into flames.
Yeah.
Okay, so you can say like re-enlighted or burst into flames.
Oh, hydrogen pop.
So what do you want to write?
Huh?
So for oxygen gas, if a glowing splint bursts into flames when placed in the gas.
Yes, I wrote.
So you can write burst into flames, or you can say relights.
Nah.
Okay, you have to write something. Glowing splint either relights or bursts into flames. Okay, awesome. A glowing splint relights when placed in a gas. Hydrogen pop test. Let's see what they wrote. Okay, so it's indicated by a pop sound or a small explosion when a burning splint is placed at the mouth of the test tube. At the mouth of the test tube. Okay, mouth of the test tube. Okay, right, instead of hydrogen pop test, right, when a pop noise is indicated by a pop noise. So get rid of hydrogen. Just to make it more like grammatically, right? So pop noise, when a burning splint is placed at the mouth of a test tube, awesome. And then carbon dioxide, I'm not, oh yeah, there's even the lime water test. Okay, yeah, so just check the wording for that. It's indicated when gas is bubbled into lime water solution and turns milky. You can keep that one, okay, whatever. Gas is bubbled into lime water. And it becomes milky. Okay, and then the next one is about the burning splint being extinguished. Right, so burning splint at the mouth is extinguished or goes out. Is extinguished at the mouth of the test tube. Are you sure it's at the mouth? I think you literally put it all the way in, but okay, check the wording for that.
Mouth.
Okay. But yeah, it does go out pretty much. Okay, now water vapor. Wait, let's check the water vapor one. Hey. Okay, so water vapor is indicated if the cobalt chloride test paper changes from blue to pink. Okay, I wasn't sure about that. Just copy paste that. Or just type in yourself.
Cobalt chloride.
I wasn't sure about this one. Cobalt chloride test paper turns blue or pink. Changes from blue to pink. Changes. Is that what it said? Go back. Okay, yeah. Okay, yes. Okay, next part. How long is this worksheet, by the way? Are we doing good? Or too slow?
We're on page 2 out of 4.
Okay, not too bad. Okay, let's work a little faster. So classify each of the following as a pure substance or mixture, and you're gonna explain your choice. Okay, so I'll give you a minute to write what you think, then I'll tell you the answer. Or we'll go over the answer together. Okay, so I go back to the definition of pure substance 1 second at the top of the first page. Okay. Okay, yeah. You can go back to your explanation now part. I was just checking one thing.
So
So you can say consists of 2 distinct parts, soap and water. I mean, I don't know if you would, yeah, you can kind of distinct, right? You can kind of like see the different parts. Okay, hydrogen gas made up of 1 element.
same response to the next one, right?
This one is made up of 2 or more elements.
Oh, this one's a mixture.
No, it's a pure substance. Because look, go back to the definition of pure substance. It can be either like made up of 1 element, or it can be a compound of 2 or more atoms. But the main thing about pure substance that it looks like 1 part. Right? So sodium chloride, it looks like 1 part, right? Like it's 1 grain of sodium chloride. Yeah, so you can write that. Yeah, it looks like 1 part, but consists of 2 different elements. Actually, write and instead of but, because we're just explaining the same thing. Awesome. And then apple juice is a mixture, but you can write it's a homogeneous mixture because it looks like just 1 kind of substance.
Of apple and water.
Yes. Okay, that's good. Okay, now classify each of the following as an element or compound. Okay, I hope you get this right. Let's try. Is an element or a compound?
Compound.
Yes, sir.
Water is a compound?
Yes. It consists of 2 hydrogen atoms and 1 oxygen atom.
What is Mg?
Mg stands for magnesium. You would find it on the periodic table of elements. Awesome. Okay, it's an element. Okay, now explanation. It's an element on the periodic table, yeah.
It's
Consists of 2 or more elements or atoms. I don't know. Is 2 of the same atoms a compound?
should I look?
Atoms, yeah.
Should I look?
Yeah, sure. So an element is made of atoms. A compound made of 2 or more atoms. Okay, awesome. Okay, and then just get rid of the S on elements, because that's bothering me, beside magnesium. Awesome. Okay, next. So draw sketches using symbols to represent 10 particles of the following. So an element. Okay, so the particle of an element, a compound, and a mixture. Okay, so the using symbols.
Can we correct?
Okay, wait, let me tell you one thing. What?
Can we correct 4 and 5? See the answers?
Fine if you want. I'm sure it's right, but okay, go ahead, check.
Okay. Mixed water, so pure, so mixtures, pure, mixture, pure mixture, and then element, compound, element. Yeah.
Okay. Now for the next part, okay, now I literally saw it, but anyway, so an element would have like one type of atom, right? Okay, like an element, let's say we take oxygen, okay? Oxygen, you can have 2 like okay, okay, so let's say an element, a single thing you would just represent. No, don't put happy face. Just put like a bunch, right? Draw 10 circles, okay? Because an element would be like one atom, one type of element. So just
Wait,
draw 10 circles.
wait 1 second. Wait 1
Or
second.
actually check the answer before you draw them, because I feel like it'll take longer. Right? You draw 10 circles. Okay, next. Sorry.
Why
Draw
10?
it. Be quick.
Why 10?
Because it says to represent 10 particles of each of the following.
So why circles?
Okay, so okay, so basically you can also do triangles if you want it, but the main thing is that all of them are from the same element, right? When we're using one shape, we're representing it as one element.
2, 3, 4, 5, 6, 7, 8,
8,
9.
9, 10. Okay, now compound. The thing about compound is that you would have 2 or more elements kind of stuck together in each particle, right? A compound, like let's say water, okay? So you would draw like at least 2 different shapes stuck together, and then 10 of those pairs.
2 shapes stuck together?
Yeah. So it can't be the same shape. It would be 2 different shapes, right?
Wait 1 second. What's going on?
Honestly, don't even draw 10. Just draw 5. Actually, no, just do all 10 because that's what they said.
I'm trying.
I need to do that. Where'd my phone go?
Okay. So 1 circle and 1 more shape. Let's do a square. Like this? Like this?
Yeah. Okay, so check the answers 1 second. But I'm pretty sure you would put like at least two different types of atoms. Okay, they just made it dark and light. But the main thing is that you are making two or more atoms together. That would make a compound.
So I'll do 10 of those.
Um,
One sec. Try.
yes.
One second. I'm gonna do something. Okay, maybe we should do this later.
Sure, yeah, you can do it later if you want.
Cause I'm gonna take
We
my
can
time.
move on.
Yeah.
Okay, yeah, sure. Okay, so let's move on to the next one.
Ah.
Okay, so if you're gonna scroll down, I can't see it. Yeah.
No, don't you want to do mixture?
Okay, yeah, awesome.
No, don't you
What?
want mixture? We didn't do mixture yet.
Okay, so for mixture, you would just put a whole bunch of different. Okay, so think of it as like water and salt. Okay, so water would be like H2O and oxygen, and then salt would be NaCl and so Na and Cl. So just put like four different shapes.
Or different. Let's see. Oh yeah.
Right? So you'd have like water and then you have like Na and Cl.
Okay, next one.
Physical or chemical property. I'm gonna let you do this because I think you can figure this out pretty quickly. If you want, just put the classification. We can do the explanation together if you want.
Okay. Done.
Okay, awesome. So, let's see now. So, blah, 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 explanation. So okay, gasoline is clear pink solution. Okay, so gasoline is a pink clear solution. Okay, if it's pink, then how's it clear? Anyways, I get the point. It's a physical property because it's just explaining the like color, so to say, right? So it's physical. Physical, ICL. Yeah. Okay, awesome. And then explanation for that is that like you can observe the color, like something like that. Okay, next one is gasoline burns in the air. That's a chemical property, yeah, because it's talking about how the gasoline, which is a hydrocarbon, reacts with like oxygen gas, right? So the fact that it burns is a chemical reaction. So with oxygen, yeah, with the oxygen in the air. Awesome. And then Water boils at 100 degrees Celsius. That is a chemical property, I'm pretty sure. Yeah. Um, explain your choice. It's a chemical property because it has to do with its like
The temperature changes.
temperature changes. Yeah. It's like it's like a chemical property of water, like its boiling point. Okay, so you can say that boiling point is a chemical property, right? Because it directly relates to the kind of composition of the substance. Okay? An electric current can split water into hydrogen and oxygen gas. That is a chemical property. I can see why you might think it's physical, and that makes me doubt it because we're creating a gas, but the fact that it's going into different elements like hydrogen, oxygen, it's splitting. I would consider that chemical property because we're chemically changing the composition, right? What do you think?
Mm-hmm. Yep.
Yep. Okay, and then ice melts above 0 degrees Celsius. That is chemical because that is a. Oh, actually, wait, let me think. Ice melts above 0 degrees Celsius. Um, I mean, in general, yeah, like phase changes are physical properties, but the fact it's above 0 degrees Celsius, it might be chemical. I don't know. I'm not exactly sure about these two. Maybe just leave it for now. And then sodium is a soft metal that is physical. Awesome. Okay, so let's check the answers. Don't write anything right now, yeah.
Physical, chemical, physical, chemical. This one's physical.
Okay, okay. Yeah, so maybe they're not talking about the actual like boiling point, but they're just talking about like the fact that it's
And
changing phase.
this is also physical.
Okay, yeah, this is also physical, yeah.
Okay.
Okay, so
And
what's the explanation they wrote for the physical ones? Boiling point can be measured without forming a new substance. Okay, so that really kind of clarifies what they are trying to, like the distinction, right? Like boiling point can be observed without forming a new substance. Okay, so let's see how far you got. Yeah, melting point can be observed without forming a new substance.
Are you there?
Yes, I'm here and I'm waiting. Okay, so softness can be measured without forming new substance. Awesome. The first two, do you want to just quickly read over the explanations in the answer key?
Color can be observed without forming new substance, and recovery describes how a substance reacts with air. Reacts with air.
Okay. Yeah, okay, so yeah, we got the main points across. So let's move on to question 8. Okay, would you want to read that?
Yeah. Okay. In 1909, Ernest Rutherford fired positively charged alpha particles at a very thin sheet of gold foil. As he expected, the majority of the particles passed through the foil. However, a small number of particles passed through the foil. However, a small number of particles deflected off the foil. Which of the following models?
Just ignore like that the first however sentence cuz
Which of the following models of the atom best explain these observations? Why?
okay, so first cross out the other however sentence cuz it's like really bad. Just
The
the
second,
first however one, just cross it out.
the first or the second?
The first.
So, um, wait, one sec. Oh, here it is. This one.
Line tool? Yeah, great.
Wait, let me just do it
And
again.
also the foil. You know, just a line tool too, right?
Yeah, yeah.
Okay, whatever, that's fine. Okay, so let me just quickly say so Ernest Rutherford, he's like a really important person, right? And his experiment is called the gold foil experiment, right? What he did is that he fired positively charged alpha particles at a very thin sheet of gold foil. Okay, so his hypothesis was that like all of the atoms will just go through gold foil, right? But as he expected, the majority of those particles just went straight through the foil and everything was good. However, a small number of particles they deflected off the foil. Okay? Now, which of these following models best describes these observations? So the thing is that at that time they didn't know that there was a nucleus in the center of the atom. They just thought that like the protons and the electrons were all just like evenly distributed in the atom. But the thing is that when those small particles deflected, it was hitting the nucleus of the atom. So, which one do you think it is? So maybe read all models and then tell me which one you think it is.
Model A, the atom is a hard sphere like these billiard balls. Model B, the atom is a positive sphere with embedded electrons like raisins in a muffin. Model C, the atom has a small, dense positive core orbited by electrons like planets orbit a star.
So you think it is?
I think it's B or C.
Okay, so it's not B because he basically proved when the small number of particles deflected, that proved that there's something in the middle, a dense positive core that actually like hit and caused those particles to deflect, right? So it's actually model C.
Okay.
Okay, so if you understood, try to like explain it. So right, the best model is model C because, and try to explain what I just said to you. Okay, let's see how far you got. So model C, because what Rutherford found out through the gold-foiled experiment was that there is a positive core called the nucleus in every atom. Yeah, that's good. When you read the answer, you can also like add to your thing. But let's move on to fill in the following table, okay? So the proton is found in the nucleus. Okay, the neutron is also found in the nucleus. Okay, and then the electron is found, I want to say around. Um, it's like kind of like just going around the nucleus, like outside. Um, yeah, you can write that for now, or you can just like check the answer after. Orbiting the nucleus works too, even though there's a reason why that is technically wrong, but yeah. Okay, and then charge, you would just write positive, neutral, negative.
How do we write neutral?
Just write neutral in words. Technically, there's like this little like like before you write degrees Celsius, that little circle, that means neutral. I don't know if you'll find it on your keyboard, but it's definitely a symbol you can use.
Mm,
It's like this little like circle.
where is it located?
Okay, no, I just leave it. I don't remember if it's like I don't remember if I do a like subscript O, or do I just like, is there a button? I don't remember, so that's fine. Okay, so for rank mass, a proton is something AMU. So right, AMU.
In capital letters?
In lowercase letters. That means atomic mass unit. A proton, I think it's one atomic mass unit. I think a neutron is also one atomic mass unit. And an electron has like a really small thing, which I don't remember. Okay, check the answers. Aha, about 0. Okay. Charge, oh, you can just write 0 for charge. Yeah. Like neutral, 0, same thing. So just write about 0. Yeah. It's an electron has like negligible mass, literally. I was gonna say nothing, but anyways. Orbiting the nucleus, you can write that. You can write around the nucleus, whatever's simpler.
Oh,
You want to change that to around, that's your choice. Well,
for this one?
yeah, you can make that 0 if you want. Okay, and then for orbiting the nucleus, if you want, you can change it to around the nucleus, or whatever makes more sense to you. Okay, now cation. Oops. Okay, which one is a cation? Awesome, and an anion. Awesome. Okay, now fill in the following table. So now we are really jumping into the periodic table of elements. You have to write the number of protons, number of electrons, and number of neutrons, I think, right?
I have it right here.
First of all, print this.
I did. The printer's not working.
Bro, what? Okay, wait. Let me see if I can give you a periodic table of elements, because it might make things a little simpler, easier to follow, so to say. I have. Wait, let me see if I can like find in the next 10 seconds. Otherwise, we'll just use your online version. Give me 1 minute.
Wait, let me go check in the printer. One second.
Configuration.
Okay, I got one printed.
Give me 1 second. I'm just looking for it. I just opened like one of my binders.
There's another one
Right,
printed.
so I'll just save you printing it, and honestly, you're gonna need it all the time. So give me 1 minute. I'm basically investing in our future.
There's a second one printed. A new fresh printed.
1 second. I'm checking. How do I not have one here? That's so weird. That's Are you kidding me? I don't have it. Oh, let me check this binder. I think I might have disowned my periodic table. Okay, so I can't find it, which is fine. We'll just print one later. I'm trying to find a periodic table. Take this. Second one printed out. Oh, awesome, perfect. Okay, go back to class. Hurry up. Okay, so yeah, we just printed one. Sorry for the delay, folks. Let's get back to it. Okay, so let's just finish one column together, and then the rest you're gonna do yourself.
Okay.
Hello? Hello?
Yeah. Yeah.
Okay.
Yeah.
Okay, so we're doing one column together, and then the rest I'm gonna let you do yourself, okay? And I'll just like kind of move on from here. So the number of protons, they come from the atomic number of the element. So on the top left, you will see a number. So for calcium, that's Ca, there's a number at the top left, 20. Okay, awesome. The number of electrons, since it's a neutral atom, and you know it's neutral because it's not an anion or a cation, so it would also have 20 electrons. Yeah, that's right. Yeah, 20. And then neutrons is also 20. Actually, no. Is it 20? Okay, let me tell you about neutrons, okay? It's 20, but let me tell you why it's 20. Hello, can you hear me?
Yeah, neutrons.
Okay, yeah. Okay, so let me tell you. So basically when you look in the Ca box, there is on the right side, it says 40.08.
Yeah.
Yeah? Okay, so that is the atomic mass of the element. So that's how much like it weighs.
Yeah. So you have the minus 40.
Okay, now we know it's 40 minus 20, yeah.
Yeah. So it's 20.
Okay, so you understand that, right? So it makes sense because the thing that's making the weight of the calcium is the protons and the neutrons, right? The electrons don't add any weight to the atom. It's like almost zero, right? So that's why. Okay, so so yeah, so just write 20 there.
But don't you round 40 to 41?
No. If it was 40.8, then maybe, but this is 40.08. So that would actually round to 40. Do you see? Because it's like not 40.8, it's 40.08. Anyways, so that's good. The rest of them, actually, let's do P3 minus together. Like these ones are pretty simple. Okay, it's P3 minus. So what is P?
Potassium.
No, it's phosphorus. Potassium is K. You have to look on your periodic table. Anyway, so you will find phosphorus on the right side of the periodic table is number 15. Its atomic number is 15, so just look where it says 15. They're in order.
Yeah.
Got it? Okay, yeah. So first I'll let you do it because you understand. Number of protons is your atomic number. Okay, good. Number of electrons. Okay, now no. The thing about electrons is that okay. Yeah, first write the neutrons. First write the neutron. Yeah, leave 15 for now, and I'll tell you why that's wrong. This is yeah where you'll round to 31, and then 16. Awesome. Okay, now for electrons, if it was a neutral potassium, phosphorus, sorry, if it was a neutral phosphorus atom, it would have, it would have 15 electrons. But as you can see, can you move your block? It's like covering the question, you know. Yeah. Okay, so it's 3 minus. Okay, now when it's 3 minus, that means that it gained 3 more electrons, right? Because it has like a net negative charge, so that means it got 3 more electrons. So no, it would be 15 plus 3, which is 18. Awesome. Okay. So that's how you would do that one. And then if it's plus, like lithium, I'll just tell you that you subtract an electron because the number of protons never change. Can you still hear me?
Yeah. Yes.
Okay. So the number of protons, remember, they never change. But if you have a positive, like lithium plus, that means it has one less electron. Okay. So we only play with the electrons.
So if it's minus, it has, and if it's plus, it loses one.
Yeah, so if it's minus, that means gaining electrons. It's becoming more negative, right? More electrons. And if it's positive, it means it's losing electrons. So when it's losing electrons, it gets more positive, okay? So I'll let you do that alone on your own time, and you can always check it. That's simple. Question 12. Okay, so below is a Bohr-Rutherford diagram of sodium. So label the diagram nucleus, orbitals, electrons, valence shell, and valence electrons. So that's pretty simple. I'll let you label that real quick.
How do I label it?
I guess you would kind of like make a line and then write the text. Right? So do that real quick. Nucleus, awesome. You don't have to number each orbit. You just have to label the valence shell, which is the outermost orbit. So you can leave first orbit as long as you like understand the point, right? Or you can just yeah, you can just say orbital. Okay, right, valence orbital there. Good. Okay, now where's the valence electron? You want to label the valence electron.
Um.
So what is our outermost electron? Yes.
Okay. Do I also have to? It says nucleus, orbitals, electrons, valence shell, and valence electrons. Wait.
Okay, yeah, so just label any electron you want, electrons.
Okay. How about orbital?
Orbital. Okay, so either you can put like 3 lines, kind of like pointing to like each orbital, or you can just write first orbital. Like you know what an orbital is, right? It's just one of those circles around the nucleus. So just try to convey that fact. However you like. Okay, good and awesome. Yeah, and then you would just write
First, second,
you would
third.
just write orbitals for that. Huh?
Oh, orbitals?
Yeah, orbitals. These are all orbitals. Orbitals. Are we almost done? This is so long. But this is very important information, so
Okay.
kinda we're getting there. It's fine. It's okay, I can see the thing.
Okay, yeah. Oh wait, didn't. Okay. Next, is this
Okay,
atom?
so is this atom stable? So tell me, what do you think determines an atom's stability?
Um, 1 second. Let me tell you. Oh yeah, if the whole circle shell is full, then that means it's stable.
Yes, okay. So the fact that either like the whole circle is full or the fact that there's no like um I don't know if I would say like no valence electrons, but like basically yeah, it would have a full valence shell. That's the best way to express it, right? So as we can see, there's only one electron in the valence shell, which means that it is unstable because a full valence shell would have 8 electrons. Okay, now if this atom can form an ion, draw the Bohr-Rutherford a diagram for that ion, and what is the symbol of the ion? Okay, so an ion is like the stable form of the element. I'll give you that hint.
I don't get
So
it.
something's gonna happen to that valence electron, and that's gonna make it stable.
It's gonna. I don't understand.
Okay, so basically, see how there's that one valence electron that is making it unstable?
Yeah.
Okay, so in order, so it's gonna either that electron is going to be lost or it's gonna gain more electrons to become a full valence. Okay, so that's like an ion is either like you gain electrons or you lose electrons. So if we only have one valence electron, we're gonna lose that electron, and then we would end up with Na plus. So the symbol of the ion is Na plus.
Wait, how do you know that?
Symbol of the ion.
How do you know
You know
that?
where it says there? Click there and write Na plus. And plus should be in the superscript. Okay, capital N.
How do you know?
Okay, it's important that you do these. Yeah, capital N, lowercase a, and plus in the superscript. I don't know if it gives you that option, but that's like the correct way to write it.
How do you know? It's Na plus.
Okay, yeah. So I'm telling you, basically, um, in order for it to form an ion. First, tell me what an ion means.
It means that it's full.
No, an ion is when an atom either loses or gains electrons. If it loses electrons, it's called a cation, and if it gains electrons, negative electrons, it's an anion. Okay? So if this atom can form an ion, the thing is that in order to form an ion, it's going to become more stable. Okay? Because originally Na, it will have 11 protons and 11 electrons. Okay? So, but in its ionic form, it would have 11 protons and 10 electrons. right? So 8 will be the full valence shell, and 2 will be from the first orbital, which has 2 electrons, right? So now you're gonna draw it in its ionic form. When you draw it out, it'll make more sense, right? So draw a circle in the ion section because you have to draw the ion, right? It'll be the exact same thing as Na, but but you will have but without like the valence electron. Okay, so you'll have all the same electrons except that one valence electron because it loses that valence electron.
I just have to redraw it.
So when it loses an electron, it's left with a net plus one charge. So Na plus.
So I just draw it again, but without the last electron, the valence one.
Yes.
Okay.
Awesome, you got it.
Yeah, can we stop now?
How much is left?
All of this.
Okay, so that's drawing. So if you want, I can like explain it to you, and then you can just do it yourself.
No, let's go.
Okay, yeah. So it's a great session. So I'll see you later. Bye.
Bye.